Hello everyone. In the previous video, I have uploaded about the rectifier concept. So in that video, you got a clear idea that where we are using the rectifier concept in electronic devices. So in that we have seen that a rectifier is an electronic device which converts the AC current to DC. So the process is known as rectification. The process of converting the AC to to DC is known as the rectification process. So in that video we have gone through the types of rectifiers. So basically we have seen the types of rectifiers. So coming to the first type of rectifier, that is the half wave rectifier. So the name itself, it shows that half wave rectifier. So half wave, so the name itself shows that the half wave rectifier has the output which is of only half cycle. So here you can see the cycle, and in the previous video we have seen the cycle. So complete cycle. So how we can say what is the cycle and what is the sine cycle, or we can say any type of sine, triangular, um, rectangle. So these are all types of signals we can see, but the natural signal, which is a sinusoidal signal, and that is the AC, which is very important to the concept for the rectifiers. So that is the AC current which we get to the homes, we have discussed in the previous video also. If you don't know, you can go through this cycle. So this is the AC. You can see this is the AC alternating current. The alternating current we are giving to the circuit. This is the circuit. This is the half wave rectifier diagram. So this is the input. This is the input given to the half wave rectifier. This is the half wave rectifier circuit diagram. Circuit diagram. Circuit diagram. See, I think so. Yeah, this is the circuit diagram. So in this video, you can see the brief explanation of half wave rectifier. If you have any doubts, uh, you can uh, you can go through this, and this is very helpful to the students who are very uh, you know in order to score good marks in your exams, as well as by listening to this video. By only listening to this video, you can write by your own in the exams also. There is no need to always keep in mind. So this is the concept you have to use about what we are giving the input and what we are getting the output is very important to the circuit diagram, and that is how we explain. That is in a theoretical way, right? Yeah. Here, input is the AC signal. So this is the AC. I have said that 230 volts we get, 230 volts. So this is a supply voltage, we can say. So this is a supply voltage. Here, this is the voltage we are getting to the home applications, or anywhere we get this input. But we don't need this much of voltage, which is the very huge voltage. We need very small voltages, very small voltages. Right, small voltages. Here you can see this is the circuit diagram. Here you no need to keep always butify anything, right? Always you have to keep in the mind concept, right? By using the concept, we can get the analysis part also, right? This is the primary voltage, and this is the right, primary, and this is the, you can see this part. Yes, this is the transformer, right? This is the transformer. Yes, here we need to know transformer. What are the windings we have? Only two types of windings we have. First one is primary winding, second one is secondary winding. So here we have two types of um, primary winding. We've used a step up and step down transformer. In this half wave rectifier, we are using the only step down transformer. Why? Because in electronic device we don't need much voltages, I mean not heavy voltages, we need a small voltages. So in order to have a very low voltage, we go through the always step down transformer. We prefer according to our application, right? Here we need only step down transformer. So what is step up and what is step down transformer? So here you see, step up transformer will increase the voltage and step down transformer will decrease the voltage. So if you want to increase the voltage, so we go for the step up transformer. If we need step down transformer, which means we have to decrease the voltage. We don't need much large voltages, we need a small voltages, so we go through the step down transformer, right? So in this half wave rectifier, we are using the step down transformer, right? This is a step down transformer we are using, and you can see this is the diode, right? This is the diode. Here diode, this is said to be cathode. See here, I am explaining very clearly because you should not have any a doubt in your mind. So from the basic, why I'm repeating, if you know already it's okay, but the students who don't know about this, if they want to know very clearly what is the anode, what is the cathode, I am going to the very clearly, very deeply, right? So this is the cathode and this is the anode, right? So here this transformer is connected series to the diode, right? And this diode is given to the output resistant RL. So here we are giving the input and here we are collecting the output. So this is the half wave rectifier circuit diagram. So you can see what is Vs also, you can know, which is nothing but the source voltage. VL is nothing but the voltage across the load resistant. So here we have a resistant RL, which is nothing but the output. Load is nothing but the output, whatever the input we are giving and what's output we are getting. So this is the half wave rectifier. So here we will see how these half wave rectifier is working principle, right? What are the cycles which are present in the half wave rectifier? So we know the positive cycle and the negative cycle, right? This is the positive cycle, this is the negative cycle, which is nothing but positive Vm, this is negative Vm. So how this is working? So you can see this is the source voltage, input which is given to the circuit, right? And you can see I'm explaining the input part very clearly, that this is the input. Vs is nothing but the source voltage. This is the input. And you can see this is the complete one cycle. This is the time period t. Small t indicates the time period. So one complete cycle from starting here to here, it is a one cycle, and next another cycle starts from here and it ends here, and another cycle. So that number of cycles we will have. Number of cycles, there is no we don't have a there will be continuation of getting the sinusoidal waveform. So here t is the time period. So you can know, I'm explaining the key point, that is t time period. Time period is nothing but number of cycles. Time, number of cycles. I'm sorry, not t. See here, this is the time period which is from 0 to 2 pi. It is it is a time, right? It is the time of a single sinusoid. Next, this input is given to the here transformer. I have said that we have to convert this voltage to very low voltage, means we have to decrease the voltage. Voltage will be maximum voltage here we get, which is a high voltage, so we don't need that much of voltage. So in order to convert, we use the step down transformer here. So concept I have explained, that why we use a step down transformer here, right? So you got an idea. So here from this step down transformer will give this is the source voltage to the diode. See here, we should know the clear idea about that diode. So diode will allow forward bias, forward bias, current, right? Forward bias current, the diode will allow. Is the diode. Reverse bias, it will not allow any current, right? So depending upon the characteristics of diode, we will get the output here, right? We will collect the voltage, load voltage, or RL. So this is the voltage we are getting. The transformer here we are using the step down transformer. By that we are decreasing the voltage and giving to the diode. The diode will conducts. Here the concept comes, that conducts means it start working. It will allow positive half cycle, and it will not allow during the conduction takes place only during positive half cycle. During negative half cycle, the diode will not allow any current. So based on that characteristics of diode, we are giving the input AC, and the output is not pure DC. It is a pulsating DC. So pulses you can see. So this is the pulses. Pulsating DC we are getting at the output. Pulsating DC. So here you can see, this is the input from, see this is the 0. You think this is 0 to pi. 0 to pi, it is a positive half cycle, so conduction will take place. So the output voltage will be VL. VL will be the output. So you can see the input is V maximum we are giving. So output voltage also we are getting the V max. But during the negative half cycle, from where? From pi to 2 pi. See here input is pi to 2 pi. So the conduction will not takes place, means the diode will not allow any current. So that's why the output of the half wave rectifier is 0. Again it will take positive half cycle. Conduction takes place. You can see here. Next here negative half cycle, it will not allow any current, it will not allow any current, and that is it is said to be 0. So thus the output will be pulsating DC. This is the output waveform of half wave rectifier. So here I would like to conclude that the input we are giving the AC current, the half wave rectifier will give the output as pulsating DC. DC voltage or DC current it is said to be. So this is the circuit diagram of half wave rectifier. So the concept, the theory you can write that is, during the positive half cycle the conduction takes place and there will be the output, but during the negative half cycle the diode will not conduct and will not allow any voltage or current. So the voltage across the output voltage will be 0 volts. So the output of rectifier will be pulsating DC. So that's all about this video, half wave rectifier. Next in the video, by using all this concept, is simply that we use the V source voltage. Source voltage is nothing but the input voltage. This is the input voltage. This is the input voltage. This is the output voltage. We are going to calculate the circuit analysis of half wave rectifier. So this is the concept of half wave rectifier. Thank you.